Hello viewers, in today's class we are going to take up the concept of probability distribution. In our previous video we have discussed the concept of a random variable, and now in this class we will study the concept of probability distribution, right? So let us first take the definition of probability distribution of a random variable x. Now if a random variable x takes values x1, x2, x3 up to xn with the respective probabilities p1, p2 up to pn, then this table, that is where the first row represent the values taken by the random variable x, and the corresponding probabilities are shown in the second row, then this table or this distribution is known as the probability distribution of this random variable x, right? So let us first take a very simple problem or an example to illustrate this definition. Now let us take the example of finding out the probability distribution of the random variable x, which denotes the number of heads in two tosses of a coin, or in other words we can say that a simultaneous toss of 2 coins, right? So here the experiment is to toss a coin twice, or a simultaneous toss of 2 coins. So the sample space S contains the elements HH, HT, TH and TT, right? So these are the 4 events, the simple events which belongs to the sample space of tossing 2 coins, right? Now here the random variable x, it denotes the number of heads, right? So we see that if we take this event, that is HH, then the value of x of HH is 2, because here we have 2 heads, and the random variable x takes the value 2. Similarly, x of HT is 1, and x of TH is again 1, and x of TT is 0, because here there is no head, right? Okay, now for the concept of random variable, the viewers can see the video on random variable. So we see that here x can take values, either 0 or 1 or 2, right? So here in our formal definition we have said that the random variable x can take values x1, x2 up to xn. So here x is written as 0, 1 and 2, because x1 is 0, x2 is 1 and x3 is 2, right? And now we have to find the corresponding probability for the different values of the random variable. Now here we see that p of 0, now p of 0, it means that the random variable x takes value 0, and it means we have to find the probability of getting no head, right? So p of 0, here we have p of 0, here we have p of 1, and here we have p of 2, right? So P of 0 implies that we have to find the probability of getting no head, right? And we see that here we have this event TT where we do not have any head. So we have the number of favorable cases to no head is 1, and the total number of cases are 4. So the probability P of 0 is 1 by 4. So here we'll write 1 by 4, right? Similarly, P of 1 implies that we have to find the probability of getting one head, right? And we see that from the sample space, the probability of getting one head can be obtained by either this event or this event. So we have two favorable events for this. So this is 2 by 4, right? So here we can write 2 by 4. Clear? Okay. Similarly, P of 2 implies that we have to get both the heads, right? Or two heads. The probability of getting two heads. Okay. So the probability of getting two heads when we toss a coin twice, or a simultaneous toss of 2 coins, then we have the favorable event is this, so HH, so the corresponding probability is 1 by 4. So here we'll write 1 by 4, right? So here the random variable x takes the value 0, 1, 2, and the corresponding probabilities are 1 by 4, 2 by 4, and 1 by 4. So therefore the probability distribution like this table we can prepare it like this. So x is 0, 1, 2, and the corresponding probabilities are 1 by 4, and this is 2 by 4, so we can write it as 1 by 2, and this is 1 by 4, right? So this is the probability distribution for the experiment of two tosses of a coin. That is the sum of all these probabilities, that is sigma px, right? Sigma px must be equal to 1, because the sum of all the probabilities should be equal to 1, right? So the sum of p1 plus p2 plus p3 up to pn must be equal to 1, right? So as here we can see that 1 by 4 plus 2 by 4 plus 1 by 4 is equal to 1 plus 2 3 plus 1 4, 4 by 4, and this is equal to 1. Now let us take one more example. So here a bag contains 4 white and 3 red balls, right? And we have to find the probability distribution of red balls in a random draw of 3 balls, right? So here let us first define the random variable x. So what is x? So x denotes this random variable x denotes the number of red balls, the number of red balls, right? Number of red balls. Okay, in a random draw of 3 balls, right? Okay, so here we have to draw 3 balls, and the bag contains 4 white and 3 red balls. So x denotes the number of red balls. So here we see that when the 3 balls are drawn, they may be all red, or we can have 2 red balls, or 1 red ball, or no red ball at all, right? So when we draw 3 balls in a random draw, then we may have all red balls, or 1 red ball, or 2 red balls, or no red ball at all, right? No red ball at all. So here we see that the random variable x, when we have all red balls, then x takes the value 3, right? And when we have one red ball, then the random variable x takes the value 1. And when we have two red balls, then it takes the value 2. And when we have no red ball at all, then x takes the value 0. So it means x can take values 0, 1, 2 or 3, right? So in this case, when we have all the red balls, then we'll have the event like R, R and R, right? And when we have one red ball, then we may have R and two white balls, right? And we can also arrange this event like W, R, W and so on. So we'll have the event like this, or containing one red ball only. And when we have two red balls, then we may have R, R, W, or this can also be rearranged like R, W, R and so on. So basically we'll have this type of event which contains two red balls, and here the event contains one red ball, and here we have three red balls, right? And when we have no red ball at all, then we'll have the event W, W and W, right? So in this way we say that this random variable x takes the value 0, 1, 2 and 3. So 0 denotes no red ball, 1 denotes one red ball, and 2 denotes two red balls, and 3 denotes 3 red balls, right? So let us now find the probabilities corresponding to these different values. So viewers, here let us first find P0. Now P0 means when x is equal to 0 or x takes the value 0. So it means P of 0 means that getting no red ball, right? No red ball. So now we have to find the probability of getting no red ball. It means in other words we can say that getting all the 3 white balls. So all the 3 white balls. So it means we have to find the probability of W, W and W, right? Now the definition of probability of an event says that the number of favorable outcomes divided by total number of outcomes. So here the probability of getting all the 3 white balls can be written as number of favorable outcomes. So we have 4 white balls and we have to select 3 balls out of 4 white balls. So this can be done in this way, that is 4C3, and the total outcomes is we have 7 balls, and because the total number of balls are 4 plus 3, that is 7, and we have to select 3 balls out of 7 balls. So this is 7 C3, right? So the probability of getting all the 3 white balls is 4C3 divided by 7C3. Now if we solve it by making use of the formula, NCR is n factorial divided by r factorial multiplied n minus r factorial. We see that 4C3 is 4, and 7C3 is 35, right? So this is 4 divided by 35, right? So P of 0 is equal to 4 by 35. So here we'll write 4 by 35. Now we have to find P of 1. Now we have to find the value of P of 1. So P of 1 means when the random variable x takes the value 1. So it means in this case we have to find the probability of getting one red and two white balls, right? So one red and two white balls. So here again applying the definition of probability, that is number of favorable cases divided by total number of cases, and here we have to find the probability of getting one red and two white balls. So one red ball can be selected out of three red balls by 3C1 ways, and two white balls out of 4 can be selected in 4C2 ways, and here we have the multiplication sign, and the total number of cases would be 7C3, right? And now we have to calculate this expression. So 3C1 is 3 and 4C2 is 6 divided by 35. So we have 18 by 35, right? So here we'll write 18 by 35. Now we have to find the value of P of 2. It means the probability when the random variable x takes the value 2, and it means we have to find the probability of getting two red balls and one white ball. So we have two red balls and one white ball. So two red balls can be selected out of three red balls in 3C2 ways, and one white ball can be selected out of four white balls in 4C1 ways, and here we have 7C3, right? So in a similar fashion, if we calculate 3C2 and 4C1, we get this is 12 by 35, right? So here we will write 12 by 35. Now we have to calculate the probability of getting three red balls, and this is P of 3, and this can be written as P of x equal to 3. So it means all the balls are red, so we have R, and again applying this definition, that is total number of favorable cases divided by total cases. So three red balls can be selected out of three red balls in 3C3 ways, and in the denominator we have 7C3, right? So 3C3 is 1 and 7C3 is 35. So here we have 1 over 35. So here we'll write 1 over 35. So whereas this table is known as the probability distribution for the random variable x when we have a bag containing 4 white balls and 3 red balls, and we have to draw the red balls in a random draw of 3 balls, right? Now here again we can verify that the sum of all these probabilities should be equal to 1. So let us see the sum of all these four fractions. So this is 4 by 35 plus 18 by 35 plus 12 by 35 and 1 by 35, and we see that 4 plus 18 is 22 and 12 plus 1 is 13 divided by 35, and this is 35 divided by 35, that is equal to 1, right? Now let us take one more important example. So here we have two cards are drawn successively with replacement from a well shuffled pack of 52 cards. Now we have to find the probability of the number of kings, right? So here what happens, we have to draw two cards, right, from a pack of 52 cards, and without replacement, it is with replacement, and we have to find the probability distribution of the number of kings. So right, so here the random variable is x, and it denotes the number of kings, right? It denotes the number of kings. Now here we have to draw two cards, and they are drawn successively with replacement, and we have to find the probability distribution of the number of kings. Now we know that there are 4 kings in a pack of 52 cards, and when we draw two cards, then in the first draw we can have a king, and in the second draw we can have a king, right? So in this case we have both the kings. So here x can take value 2. So we can say that when we have kk, it means in the first draw we have the king, and then we have replaced the card, and then we have again drawn the card, and again we have got the king. So the event kk means we are getting kings in both the draws, right? Okay, now suppose if we get the king in the first draw and a non-king, right, that is the card other than king, and we can denote that card by say nk. Nk means a non-king, right? And in this case we have only one king, right? So here in the first draw we have the king, in the second draw we have a non-king card. Similarly, let us take the condition where we have the first draw results in a non-king card, and the second draw results in a king, right? And let us take the condition or the case where we have no king in both the draws, right? So it means we have nk, that is a non-king card, and here also we have a non-king card, right? Okay, so what is the situation here? So x denotes the number of kings, and in a well shuffled pack of 52 cards we have 4 kings, and we have to draw 2 cards successively with replacement, right? And we see that there may be 4 situations. Either in the both the draws we have both kings. In this case the first draw results in a king, and the second draw results in a non-king card. In this case the first draw results in a non-king card, and the second draw results in a king. And in this case we do not have a card king in both the draws. So it means we have a non-king card in both the draws. So here we see that x takes the value 2, here x takes value 1, here also x takes value 1, and here the random variable x takes the value 0. It means in this event we have 0 kings. In this event we have 1 king, here also we have 1 king, and here we have 2 kings. So we conclude that x takes the value 0, 1 and 2. Now we have to find the probabilities, that is for x equal to 0, for x equal to 1 and for x equal to 2, right? So P of x equal to 0 implies no king, right? It means no king. Here it implies one king, right? And here we see that we get both the kings. So both kings, right? Okay, now we'll calculate these probabilities. Now here if we want to calculate the probability of no king, it means we have this event, that is nk and nk, right? That is non-king. So here we have in the first draw we have the card which is not a king, so we have 48 divided by 52, and in the second case also, when we have replaced the first card, then we have the probability of getting a non-king is 48 by 52, right? So here we have applied the formula for probability of A union B, that is A intersection B, sorry, it is A intersection B, so it is PA multiplied PB, where A and B are independent events. These are independent events, right? Okay, so here we have no king, it means a non-king and non-king, right? So non-king can be obtained by 48 by 52. Similarly, again for non-king we have the probability 48 by 52, right? Okay, now if we calculate it, then we get 144 divided by 169, right? Now come to probability of getting one king. Now one king can be obtained either in the first draw or in the second draw. So we have these two cases. In this case we have these two cases. So what we will have? So we can write this as PK, that is king and non-king, plus probability of non-king and king. Clear? So this expression shows that in the first draw we have obtained a king, and in the second draw we do not have a king, and this probability shows that in the first draw we do not have a king, and in the second draw we have a king. So here these two are independent events, so we can apply this rule, because here this is A, this is B, and this is the intersection, so this is PA multiplied PB. So here again this is A, this is B, and this can be written as, in the first draw we have the king, so this is 4 by 52 multiplied 48 by 52, plus here we have in the first draw a non-king, so we have 48 by 52 multiplied, the probability of obtaining a king is 4 by 52, right? Now see these two numbers are same, so we can multiply it by 2, so we have 2 times of 4 by 52 times 48 by 52, right? And if we calculate it, we get 24 divided by 169, right? Okay, so here for px of 0 we have 144 over 169, so here we can write 144 over 169, and for p of x equal to 1 we can write 24 divided by 169. Now let us come to the third one. So here we have to find p of x equal to 2. It means we have to find the probability of getting both the kings. So it means we have to find pk and pk, right? Or in the terms of this formula we can write p of k intersection k. So we can write pk, that is probability of getting a king in the first draw, multiplied the probability of getting the king in the second draw. So this is pk. And what is p of k? That is 4 by 52 multiplied 4 by 52, right? And if we calculate it and simplify it, we get 1 over 169, right? And here the probability of getting both the kings is 1 over 169. So this is the required probability distribution for this problem.